This lesson is on simplifying rational expressions. By the end of this lesson, you should be able to simplify rational expressions with and without factoring. So make sure you have your factoring cheat sheet next to you. Simplifying a rational expression into its lowest terms is an extremely useful skill. In algebra, its algebra is based on how we simplify numerical fractions. The basic principle is developed in the first exercise. So recall that to multiply fractions, one simply multiplies their numerators and denominators. So to simplify the numerical fraction 18 over 12, by first expressing it as the product of two fractions, one of which is equal to 1. So what can I divide into both 18 and 12? Hopefully you're saying 6. So I'm going to factor the numerator into 6 times 3. And I'm going to factor the denominator into 6 times 2. Now what if you just did prime factorization? That would work also. So if you'd used prime factorization in your calculators, you would have had 2 times 3 times 3 over 2 times 2 times 3. So either one is possible, whichever one you like better. These are equal, so it does not matter. And now you're going to say to yourself, what divides to 1? Well, 3 divided by 3 is 1. 2 divided by 2 is 1. So, do I have to write all these ones? No. Sometimes we slip and say they cancel. I prefer you say they divide into 1 so that we remember that those ones are there. So what is 1 times 3 times 1? It's just 3 over 1 times 2 times 1, which is 2. So every time you think in your head, oh, they cancel, correct yourself and say they divide to equal 1. Okay? That will help you in the future. Notice these are all attached by multiply. That's what allows me to divide them. Okay? I cannot divide things if they're attached by pluses and minuses, only when they are attached by multiplies. All right? So we're going to simplify the algebraic expression x squared minus 9 over 2x plus 6 by first expressing it as the product of two fractions, which means we are going to factor, one of which is equal to 1. So how do I factor x squared minus 9? So if I'm looking at my helpful sheet, the first kind of factoring we've ever learned was GCF. It is not a GCF. It has two terms. Both terms are perfect squares, and it's a difference. So this is called a dots. So I make my two sets of parentheses. What's the square root of x squared? X. And what's the square root of 9, or the perfect square of 9, is 3 and 3. One is a plus, one is a minus. On the bottom, I start the process again. The first kind of factoring I learned was GCF. Look at that, there is something in common, a 2. So I divide out the 2, and I have x plus 3 left over. So now I know that I can cancel things or divide things into 1. Because these two factors are attached by multiply, and these two factors are attached by multiply. So I can say x plus 3 divided by x plus 3 is 1. So now my answer is x minus 3 over 2. Excellent. So every time we simplify a fraction, we are essentially finding all common factors of the numerator and denominator and dividing them to be equal to 1. Key in this process is that the numerator and denominator must be factored, and only common factors divide to 1. This is true whether our fraction contains a monomial, a binomial, or polynomial expressions. So go ahead and highlight the bolded part in that paragraph, and let's look at exercise 2. To simplify a rational expression, both the numerator and denominator may be divided by a common factor. When we do that, we say that we have reduced the fraction to its lowest terms. So in exercise 2, simplify each of the following monomials, dividing by other monomials. So think about monomials. Mono, one term. That means there's no addition and subtraction. Everything is attached by multiply. So we're going to use the same idea we used above in part A. We're going to factor everything out. So this fraction becomes 3 is prime, x to the 5th, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I have 5 x's and 6 y's. The number 6 can be broken down into 2 times 3, 8 x's and 3 y's. Now I can divide to equal 1. So 3 divided by 3 is 1. 5 of those x's divide by 1 to 5 of those x's on the bottom. 1, 2, 3, 4, 5. So those are all 1s. See how it gets kind of crowded? So that's why we don't write those 1s. And 3 of the y's. So what's left on top? Just 3 y's. So y to the 3rd. What's left on the bottom? 2 and x to the 3rd. So if you don't want to write all those variables out, you can use what you've learned in the past. Hint, hint. So divide the numbers. 20 divided by 4 is 5. What do you do when you divide exponents? You subtract them. So this is x to the 8th. And there is no more y's, so y to the 8th. I don't even need a fraction bar. I could put a 1 down there, but I don't have to. I can only do this because these are monomials. Unlike part B above, that was not monomials. Those were binomials, so I needed to factor them. Okay, if that's confusing, then factor. In part C, 7 over 21 is 1/3. There are 3 x's on top and 5 on the bottom. So that means subtracting, there are 2 left over and there's more on the bottom. There is 1 y on the top and 8 on the bottom. So subtract, I have 7 left and they too are on the bottom. Why? Because there's more on the bottom. So my answer is 1/3x² y to the 7th. Pause the video and try exercise 3. Hopefully you got your answer of choice 3. All right, let's look at exercise 4. When simplifying rational expressions that are more complex, including addition and subtraction signs, so we're talking about binomials, trinomials, polynomials, always factor first, then identify common factors that can be eliminated. So in number 4, we now have pluses and minuses, which means we must factor. So must factor with pluses and minuses. Must. So trinomial, is there anything in common? No. There's not a number in front, so it's the easier of the kind. What multiplies to -14 and adds to 5. So x and x, hopefully you said 7 and 2. I need a positive, so the bigger one must be positive, 2 must be negative. On the bottom, no GCF. It's a binomial, and they're both perfect squares, so it's a difference of 2 perfect squares. So x minus 2 and x plus 2. Now you're saying, they both have factors of x minus 2. So x minus 2 divided by x minus 2 is 1. So my answer is x plus 7 over x plus 2. If you want to keep them in parentheses, have at it. If you feel comfortable and you're good at factoring, why don't you pause the video and attempt B and C, because all this is a bunch of factoring. And then play the video to check your answers. So here are your answers to part B and part C. Notice when I get all done with these answers, I don't try to do anything funky at the end. I can't cancel x and x because they're not factors. X is not a factor on the numerator. It is added to 7. So if it's attached with a plus or a minus, I can only do the division by 1 or division to 1 if they are factors. Okay? If you need more clarification on that, please ask. Exercise 5 is huge. That's why they're starred and boxed. So we're showing you the numerical reason in A and C, and then we're showing you the generalization in B and D. So in A, 9 minus 6 is 3. 6 minus 9 is negative 3. 3 over negative 3 is negative 1. So if I do the same thing and replace 9 with A and 6 with B, and B with 6 and 9 with A, which is what we said, then this answer is negative 1. So if the factors are the same numbers or the same terms, but in the reverse order and attached by subtraction, then they can divide by each other, but they leave behind a negative 1. In part C, 3 plus 2 is 5, 2 plus 3 is 5, so that equals 1. Because order does not matter with an addition because it's a commutative property. So x plus y and y plus x. So it doesn't matter if I replace 3 plus 2 or 2 plus 3, this is always still going to divide and equal 1. So when you're adding, the order doesn't matter. When you're subtracting, if they're the same terms in each part, and they're the reverse order, both attached by subtraction, then they divide and equal a negative 1. Notice I do not have any conditions for if the signs are different. So like up in this example, I didn't try to divide x plus 4 and x minus 4 because I can't. So that's why there's no rule for that. So you got to be very careful when you have things reversed. If it's a subtraction, they can divide and equal negative 1. If it's an addition, then that's commutative property. They still divide and equal 1. So let's look at exercise 6, 7, and 8. So in exercise 6, again, we have a binomial and a binomial. So we are going to factor. So the top is a GCF, and the bottom is a difference of two perfect squares. So on top, the GCF is 2. So we get x minus 5 inside. And the bottom is 5 minus x and 5 plus x. So this is my first scenario. I have x minus 5 and 5 minus x, exactly like part B. So I am going to divide them, and they divide and equal negative 1. Well, what do I put on the bottom then? Positive 1. Because negative 1 over positive 1 is negative 1. I do not put a negative 1 on the top and bottom, right? So now my answer is negative 2 over 5 plus x. That answer is not here. But in choice 1, they reversed this order. And we know by the commutative property, that's okay. So our answer is choice 1. So why don't you pause the video and try to do exercise 7. And play the video when you're ready. In number 7, you should have gotten the answer of 4. And you can see my work. I came out with negative 1 times x minus 3 over 6. I distributed the negative 1 in. I got negative x plus 3. So I just reversed the order because it's addition. So a positive 3 and a negative x, and my answer is choice 4. All right, add it again. Pause the video and do exercise 8, part A, B, and C. Factor away and divide your common factors to equal either ones or negative ones, and simplify. Good luck! Continue the video when you're ready. Hopefully this is what your answers look like. If you have any questions and you need to go over any of these, please don't hesitate to ask in class. Good luck! See you tomorrow.